In triangle ABC, medians AD and BE intersect at G, and triangle AGE is equilateral. Then cosine C can be written as m root p over n, where m and n are relatively prime positive integers, and p is a positive integer that's not divisible by the square of any prime. What is m plus n plus p? So as the title of this video suggests, we're going to solve this problem using barycentric coordinates. If you don't know what barycentric coordinates are, then I highly suggest you check out my friend's video on them, which I will post down in the description below. So I'll briefly summarize what barycentric coordinates are here, using triangle ABC, and then we can do the problem. So suppose we have triangle ABC, points A, B, and C, and let P be a point in the plane of triangle ABC. It doesn't have to be inside ABC. It can be outside ABC too, but for now let's just put it inside triangle ABC there. Then the barycentric coordinates of point P are given by the following numbers. We have the area of BPC over the area of ABC is the barycentric coordinate with respect to point A. And then point B gives P the barycentric coordinate equal to the area of APC over the area of ABC. And the barycentric coordinate with respect to point C is equal to the area of APB over the area of ABC. And all of the areas on the numerators are directed areas. They have a sign. They're positive if P is on the right side of them, on the same side of them as the inside of triangle ABC, and negative otherwise. So the first barycentric coordinate, the area of triangle BPC over the area of ABC, would be negative if P was on the other side of BC and not on the same side of BC as the interior of the triangle. So if P was somewhere there, then the area of BPC over the area of ABC would be negative in this case. So that's a brief overview of what barycentric coordinates are. So we can now go back to the problem and decide which triangle should we use the barycentric coordinates on. Well, a good choice for our reference triangle is triangle AGE, because it's equilateral and point G is the centroid of ABC, so we can easily get the location of other points in ABC by using the centroid properties. So let's zoom in on triangle ABC and use reference triangle AGE for our barycentric coordinate system. So we're going to put A at the point 1, 0, 0. Point G will be at 0, 1, 0. And E will be at 0, 0, 1. And any point in the plane of triangle AGE, it's clear that any point will satisfy the property that the sum of the barycentric coordinates is equal to 1. Because again, looking back to our definition of each of the barycentric coordinates, the sum of these values is equal to 1 if we direct them based on what side of BC, CA, and AB they're on. So let's go back to triangle AGE and fill out the locations of the other points. We know that E is the midpoint of AC because BE is a median. That's what it means. BE is just the line that's drawn from B to the midpoint of AC. So E is the midpoint of AC. And so we must have that C is located at point -1, 0, 2. Because that way the average of each barycentric coordinate in A and C is equal to the corresponding barycentric coordinate of E. And now to find the location of point D, well, we know that the centroid divides AD into two segments whose lengths are in the ratio 2/1. It follows that since the A barycentric coordinate of A is 1, and that of G is 0, it must be that the A barycentric coordinate of D is equal to -1/2. And similarly, the G barycentric coordinate of D is going to have to be equal 3/2. Because we went from 0 to 1 between A and G. We have to go another half to get to D. And now all points on AG have the property that the E barycentric coordinate is equal to 0. So that's just 0. And we know that D is the midpoint of BC, so we can fill in the location of point B. That should be equal to 0, we know that the A barycentric coordinate of B is equal to 0 because it lies on line GE, which is the side opposite A. So all points on that line have A barycentric coordinate 0. And then the G barycentric coordinate of B is the number such that 3 over 2 is the average of 0 in it. So that would just be 3. And then the E barycentric coordinate is going to be negative 2. And this actually makes sense because it can be verified that point G lies 2/3 of the way between B and E. 1 is 2/3 of the way between 3 and 0, and so is 0. That's also 2/3 of the way between negative 2 and 1. So we've got the locations of all the points we need in triangle ABC. Now the problem asks us to find the cosine of angle C. So how can we do that? Well, the cosine of angle C, it turns out that we're going to use the method known as the dot product method to find the cosine of angle C. The dot product method is pretty simple. We have two vectors, vector A and vector B, in 3D space. And suppose they both emanate from point C, which we can set as the origin. It doesn't really matter where point C is. So we can set C to be the origin. We can also set A to be x1, y1, z1. And then we'll assume that B is equal to x2, y2, z2. Then the dot product method for cosine, it states that the cosine of the angle theta between the two vectors is going to equal the following. It's going to equal the product of vectors A and B, dot product, over the product of the magnitudes of A and B. Now, the dot product of A and B in terms of x1, y1, z1, and x2, y2, z2, that's just equal to x1, x2, plus y1, y2, plus z1, z2. And the product of the magnitudes of A and B, well, that's just equal to the distance CA times the distance CB, which is just the square root of x1 squared plus y1 squared plus z1 squared times the square root of x2 squared plus y2 squared plus z2 squared. So we can use that here. If B is equal to 0, 3, negative 2, here, C is equal to negative 1, 0, 2, and A is equal to 1, 0, 0, we can just shift everything over by 1, 0, and negative 2 so that C is now the origin. And then we can use exactly this formula to find cosine C. So I'll do this on down here, where we can still see the locations of A, B, and C. So the new location of point B, after shifting everything by 1, 0, negative 2, so that C is now the origin, we get that B is mapped to the point 1, 3, negative 4. And A, after the shift, would get mapped to the point 2, 0, and negative 2. And C would obviously end up at the origin, 0, 0, 0. If we want to find the cosine of angle C, then we have, from this, cosine theta equals the product of vectors A and B over the product of the magnitudes of A and B. We find that cosine C is just equal to x1, x2 plus y1, y2 plus z1, z2. So that's just 1 times 2 plus 3 times 0 plus negative 4 times negative 2, which is just 2 plus 0 plus 8 in this case, and that's equal to 10. Over the product of the lengths of CA and CB, well, that's just the square root of 1 squared plus 3 squared plus negative 4 squared, which is just the square root of 1 plus 9 plus 16, which is the square root of 25 plus 1. So that's the square root of 26. And the length of CA is equal to the square root of 2 squared plus negative 2 squared. And that's equal to the square root of 4 plus 4, which is equal to the square root of 8. So this is equal to 10 over the square root of 208. And that's cosine C, which is what we want to find. So this is equal to 10 over 4 root 13. If we multiply both the numerator and denominator by root 13, we get that this equals 10 root 13 over 52. However, m and n need to be relatively prime, so we divide both m and n by 2. We still get the same thing. Cosine C equals 5 root 13 over 26. So m is equal to 5, n is equal to 26, and p is equal to 13. So m plus n plus p is equal to 5 plus 26 plus 13. And that's equal to 31 plus 13, which is 44. And that is equal to answer choice A. We are done. So this was another problem that could be solved using barycentric coordinates. I don't recommend you do this on the real exam, obviously, but I just felt the solution was too good to not share. And that's why I uploaded this video. So thank you all for watching my YouTube video. I hope you enjoyed. Please follow my channel if you would like to see more videos. And please help me get to 200 followers before the AMC 12B on Tuesday, November 14. And 400 followers before the AMI on January 31.